Hello and Assalamualaikum to everyone. My name is Sharifah Shakira and I will explain to you what is the meaning of differentiation and what are the techniques. Differentiation is a method of finding derivative of a function. It's a key concept in calculus that helps us understand how things change, which tells us the rate of change at any point. There are 5 rules that we learn in differentiation, which are constant rule, power rule, product rule, question rule, and chain rule. If x is independent variable and y is dependent variable, then the rate of change of y with respect to x is given by dy over dx. This is the general expression for derivative of a function and is represented as f prime x equals to dy over dx, where y equal to fx is any function.
Hello everyone, my name is Differentiaton and for my part I'll be doing question 2A and B. So let's get started.
So for part A, function is product of 2 parts, which is x squared and log tangent x. So to solve this problem I used product rule. So I will let u equals x squared and b equals log tangent x. To differentiate u, we simply use power rule, so we got 2x. And to differentiate b, I use chain rule since it's a log of trigonometric function. So the derivative of log tangent x, which is v prime, is secant squared x over tangent x. And then I apply the product rule. First times derivative of a second plus second times derivative of first. After a bit of simplifying, I get the final answer, which is x squared secant squared x over tangent x plus 2x log tangent x. And for 2b, this one is a fraction, so we need to use quotient rule. The top is e to the power of 1 minus x and the bottom is x squared plus 2 cubed. To differentiate the top, I use chain rule. The power is a linear function, so I multiplied by -1. For the bottom, we use power rule and chain rule together. I bring the power down, keep the bracket, and multiply by the derivative of the inside. Then I plug in everything to the quotient rule. Bottom times derivative of top minus top times derivative of bottom all over bottom squared. After that, I just do a bit of factorization and simplification. So the final answer is a simplified fraction with -e to the power of -x plus 1 in the numerator and the denominator to the power of 4. So this is it for my part. Thank you.
Hi and Assalamualaikum. My name is Muhammad Nazhan bin Abdullah. So here's the question number 3. We need to find dy over dx of these functions by using implicit differentiation. So let's solve this problem. Hi and Assalamualaikum. My name is Muhammad Nazhan bin Abdullah. So here's the question number 3. We need to find dy over dx of these functions by using implicit differentiation. So let's solve this problem. Hi and Assalamualaikum. My name is Muhammad Nazhan bin Abdullah. So here's the question number 3. We need to find dy over dx of these functions by using implicit differentiation. So let's solve this problem. Hi and Assalamualaikum. So actually, we can differentiate these functions separately like what I labeled here. So let's look at the first function. We want to differentiate y ln multiplied by 3x. We notice that this is actually a logarithmic function, which means we can differentiate it by using a product rule. So first off, we need to find u and v. The value of u and v here we need to differentiate so that we got the value of u prime and v prime, just like what we got here. So after we got all of the value, we just need to put in the value here and then we simplify, and finally we got the differentiation for the first function. Now let's look at the second function. we want to differentiate negative cos multiplied by 4y. This is a trigonometric function. We can differentiate it by using a triangle like here. What we need to do is we need to find for the f gx and gx first, like what I do here. After that, we need to differentiate both of f gx and gx so that we will get the value of f prime gx and the g prime x. So let's put in the value here, and then we simplify as usual, and then we got the differentiation for the second function. And then let's look at the third function. We want to differentiate x to the power of 3 minus exponential to the power of 2x plus 1. So look at this one first, x to the power of 3. We just need to differentiate it as usual so that we got 3x to the power of 2. And then to differentiate this exponential value here, we need to use the derivatives of exponential functions, which is here. And then we need to find the value of e to the power of gx and g prime x. So g prime x is basically the differentiation for the exponential power here. And then after we got the value, we just need to put in the value here, and then we simplify, and then we simply got the differentiation for the third function. So this is the overall for the implicit differentiation. So this free differentiation that we've got from these functions, we just need to put them in the standard form, like what I do here. And then second step is we need to rearrange them. Look at here. This is the only functions that don't exist with dy over dx. So we need to put it on the left hand side so that it will become negative. If you notice that, this is a fractional form. So if we simplify, we don't get the value of dy over dx. So we need to divide all this term by x. And then for the left hand side functions, we need to factor out like here. And then we simplify, and finally we got the value of dy over dx here. So that's all from me. Thank you so much.
Welcome and hi everyone, my name is Ahmad Daniel, and today I'm going to show you on how to use techniques of differentiation to solve a question. So heading to my tablet, the question for us is to use linear approximation to estimate the value of the equation correct to 3 decimal places. So the formula of linear approximation is Lx equals to fa plus f prime a times x minus a. So what are these? So fa is function value at point A, and f prime a is the derivative at point A, and the x is the value given in the equation, and a is 1. We choose 1 because it's the closer value to 0.98. So to find fx, we just need to rewrite the equation and change the value into x. And then we can rewrite 4 to the square root of x into x to the power of 1 over 4, and rewrite this again so that it becomes 3x to the power of negative 1 over 4. So to find the f prime x, we need to differentiate this equation. Ln x, differentiate, it becomes 1 over x, and negative 3x, we bring this negative 1 over 4 down, times, and negative 1 over 4 minus 1 is negative 5 over 4. So if we times this one, we get negative 3 over 4 x minus to the power of minus 5 over 4. So after finding the f and the f prime x, we can apply the value of a equals to 1. So f1 equals to ln 1 minus 3 times 1 to the power of negative 1, 4. So ln 1 is 0, and 3 times 1 to the power of negative 1 over 4 is 3. So we get negative 3. And for the f prime 1, 1 over 1 we get 1, and then minus 3 over 4 times 1 to the power of negative 5 over 4. So 1 to the power of negative 5 over 4 is 1. So negative 3 over 4 times 1 is negative 3 over 4. So we minus 1 and we get 1 over 4. And then we can apply the linear approximation formula, which is L. Insert the value of the equation, which is 0.98. equals to f1 plus f prime 1 times 0.98 minus 1. So we get negative 3 plus 1 over 4 times negative 0.02. So we get negative 3.005, which is closer to the value that is given in the question. So when we use the calculator, we get negative 3.035. So that's how you can use the linear approximation formula to find the value that is closer to the question. And that's how you can do it. Thank you.